Tes suara Dr. Syakirin.
Boleh.
Okay, Alhamdulillah. Okay, saya dah start recording ya. Okay, Assalamualaikum, very good morning all students from group 5B and 5A. So today is week 10B, our second session for week 10. So today's topic should be state space technique. So let's begin our Friday morning session with recitation of dua. Volunteer from a male Muslim student before we start our lecture.
Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala rasulillah. Allahumma iftah 'alaina hikmataka wa anshur 'alaina nuraka min rabbi shrah li sadri wa yassir li amri wahlul min lisani yafqahu qawli. Alhamdulillahirabbil alamin.
Amin ya Rabbal Alamin. Thank you, Ashraf. Okay, so for today's topic is state space technique. This is our week 10, so we have another 2 topics left before we finish by week 14, and the next topic is digital control. So today's speaker is Dr. Muhammad SYAKIRIN RAMLI from Fakulti Teknologi Kejuruteraan Elektrik and Elektronik Universiti Malaysia Pahang. So I would like to invite Dr. SYAKIRIN to start the lecture.
Okay, thank you very much, Dr. Najidah. Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning to all of the students and all of you. So inshallah, I will start to, first of all, I would like to thank Dr. Najidah for inviting me for the session. And then previously, we have Dr. Najidah sharing her knowledge with my students. And now this time is going to be my turn to be collaborating with her in teaching you guys about the one of the topic chosen, which is the state space. Right, before we start, can you guys see clearly my screen? Boleh nampak ke screen saya ni?
Boleh.
Boleh. Alright. And then I'm not sure whether the one page note is already synchronized with your account. For example, if I do editing from my side, will you be able to see whatever notes or whatever that I wrote down on my in my screen here? Will you be able to see them clearly? Kalau saya buat sini kan, okay. Is it gonna appear in your side or there's nothing happen on your side?
Dr. Syakirin, I think you have to use the collaboration space tab, not from your folder.
Okay. Collaboration space. So it's gonna be this one, right?
Betul.
Okay. So I just discovered it. Right. But if you don't mind, I will be using from the PDF itself because it will appear clearer, kan? Dia akan nampak lagi besar kalau kita gunakan daripada PDF ni. But if I want to do some notation of if I will do the handwriting or to do explanation as well, I will be using this collaboration space. Right. So before we start, let me do some recap. So these are the information given by Dr. Najidah. So you guys already in the week 10 of the semester, and these are the topic that have been covered by Dr. Najidah. So for today, I will be discussing only on a certain part of this topic, and then due to the time given to me, I believe that I will not be able to complete everything. So only some part from the topic or from the slide that has been given to me, and the rest will be continued again by Dr. Najidah. Right. Okay. So let me go to the slide here. Okay. So today we will discuss on the topic of the state space. Okay. And these are the subtopic that has been highlighted or has been stated in this page. So basically in this topic, we will be learning about the state space equation. And then we will also learn about the eigenvalues and what is the relationship or the correlation between the eigenvalues with the closed loop pole of the system. And then I believe that most of you have already you already have some understanding about what the transfer function is all about, and then how to identify what are the zeros of the system, what are the pole, what the difference between the open loop transfer function, closed loop transfer function, and etc. And the other way of modeling, the another approach to get a model of a system is by using state space. Okay, instead of using a transfer function. Other than using a transfer function, we can also use a state space to get the mathematical model to express the mathematical model of our system. And of course, this is the some of the topic that we will be discussing today. And then, of course, you should have some understanding on how to do conversion. Okay, suppose that you are given the function and how to obtain the equivalent state space representation for that particular transfer function. All right, and same thing. If we are given the state space equation, we must be able to get the equivalent transfer function for that particular system. And then the signal flow graph, the state space representation and controllability and the observability. So these are the components that you will be learning throughout these topics. Right. Okay, and then these are the learning outcomes ataupun what are the attributes or the outcomes that we expect student will be able to get by the end of these topics. And the first one, we expect that the student should be able to explain the concept and the technique of the state space. Okay, and then you must be able to do conversion from the transfer function and state space representation. Maknanya you boleh convert daripada transfer function pergi kepada state space, or from the state space to get back into the transfer function. You have to get the knowledge on how to do this conversion. Okay. And then we also expect that student will be able to determine the controllability and the observability of a given system. Okay, so how can we know the system is controllable? How can we know that system is observable? So that will be the knowledge ataupun the techniques that you will learn from these topics. All right. Okay. In terms of course outcome and the program outcomes mapping, I believe this is apa tu the outcomes, the statement of the course outcome that has been highlighted by your instructor, and then I believe most of you have already familiarized with these course outcomes and the program outcomes. And then of course between institutions they will have a different program outcomes. For example, UNP, we have a set of program outcomes. But all the university in Malaysia are following the same guideline provided by the EAC, okay, Engineering Accreditation Council. They highlighted several program outcomes, the attribute that must be achieved by students. So normally we formulate our program outcomes based on the guideline as provided by the EAC. Right. So the course outcomes will be the attributes or the outcomes that we expect that student will be able to get by the end of this course. Right. So these are the two course outcomes, and then we just going through briefly on this mapping of CO and PO. Right. Okay. So in this table, we do have a comparison between the classical and the modern control approach. Okay. What you learned previously, okay, what you learned in the previous week, you started with the learning on the transfer function, you learn about the root locus design, you learn about the lead compensator and so on. So all these techniques are using the transfer function as the main block ataupun as the main mathematical representation of your system. Okay, maknanya kamu gunakan transfer function untuk kamu dapatkan untuk kamu fahamkan dynamics of the system. And then these are the topics that you have discovered ataupun you have learned from this by using a transfer function. So kita panggil apa teknik bila kita gunakan transfer function ni, kita panggil dia sebagai classical control punya approach. We call that as the classical control. So the way we design controller, the way we design ataupun we tune our controller, we will be using all these techniques. Either we can use the root locus plot, both diagram, Nyquist plot and Nyquist chart. So all those things use the transfer function as the main mathematical as the main we use the transfer function as the main mathematical model to represent the system. Okay. Sebelum kita boleh design by using all these technique, root locus, both diagram dan sebagainya, we need to get the mathematical model expressed in terms of the transfer function. Right. Another way ataupun another approach of designing controller, we call it as a modern control. Okay. Classical control kita guna teknik transfer function. Modern control we use another representation to model our system. Okay. For that we will use the either state space ataupun kita gunakan time domain lah, ataupun specifically we will be focusing on the state space. So of course there are limitations between these two approach. Okay, as you can see from the information provided in the slide here. Okay, we got the transfer function analysis. Transfer function is applicable only to a linear time invariant system. Okay, if we were to design our controller, we have to make the assumption that our system ataupun the plant to be controlled must be an LTI system. Okay, linear time invariant system. And then we have to limit our system to be only on a single input, single output kind of system. Maknanya kamu ada satu input saja dan kamu ada satu output. Okay. And then the function only reveal only a reveal only the system output for a given input but provide less information on the internal behavior of the system. Right, itu limitation lah. Okay. Kalau kita nak gunakan classical control, ataupun when we want to design our controller, if we want to design atau tune our controller by using all these technique, the system will be we have a limited information if we were to use the transfer function as our model block for the system to be controlled. But if we use a state space equation, okay, there are certain advantages. Maknanya we instead of have a single input, single output representation of system, we can now have we call it as a multiple input, multiple output. And then of course, if we have rich information from our system, there are a lot more that we can design lah kan. Kita boleh design macam-macam dan kita boleh dapatkan, we can ensure that the performance of our overall closed loop system. Right. Ya, setakat ni ini lebih kepada penerangan berkenaan dengan perbezaan antara classical control dan juga modern control. Right. So now let us try to understand about the state space. Okay, what the state space is all about. So state space representation is a mathematical model of physical system as a set of input, output and state variable. Okay, kita katakan state space ini is a mathematical model of physical system, okay, as a set of input, output and state variable related by first order differential equation or difference equation. We can express our state space equation, a state space system in terms of differential equation if we were to consider a time time domain punya representation, or difference equation if we were to consider for the discrete time equation. Kita gunakan differential equation bila kita consider bagi continuous time punya sistem. Kita gunakan difference equation bila consider bagi discrete time. Dah belajar kan discrete dan juga continuous? Belum lagi. Okay. So of course there is a slight different in terms of equation for the differential equation and a difference equation. So nama beza kita ada differential equation and the other one is going to be difference equation. Difference equation is the state space equation used for a discrete time system, discrete time representation. Right. A system is represented by, in the state space, will have the following general equation. Okay, kalau you baca paper ataupun you baca research paper, you buka textbook dan sebagainya. So this is the representation of a state space equation. Maknanya kamu akan ada bentuk equation nombor 1 dan juga equation nombor 2 ni. Ini adalah standard equation untuk state space. So you nampak ni, so we call it as a state space equation. Whereby this is given in terms of differential equation. Kan, ini adalah differential equation. And then we got x dot of t equal to ax of t plus bu of t. Okay, y of t equal to cx of t plus du of t. Okay, x of t is a vector. Okay, a first order differential equation vector. A is we call as the system matrix. Kita panggil matrix A sebagai system matrix. And then we got x of t is our state vector. Kan, x adalah kita punya state vector. And then we got our u ni, ini adalah control input ataupun control vector, input or the control vector. And then we got b as our input matrix, and d is going to be the feed forward matrix. Okay, feed forward matrix. Right. So when we talk about the state space equation, you in your mind you should get this representation. Okay, you kena, bila kita katakan state space je, you kena nampak x dot sama dengan ax plus bu, y of t sama dengan cx plus du. So itu adalah kita punya state space equation, dan the names of these parameters ataupun all these blocks is the one that listed here lah. Kita panggil A ni sebagai system matrix, B input matrix, C sebagai output matrix, D sebagai feed forward matrix. Okay, A, B, C, D, and then we got x of t as our state vector, y of t as the output vector. Okay. U adalah input. Kita ada input, kita ada state, dan kita ada output. Right. So x of t comes from the state equation, y of t comes from the output equation. Okay. So this is the representation of the equation that we have in this slide. Kan, daripada equation 1 dan 2 ni, we can get the equivalent block diagram. Okay. Tapi ini bukan, kalau tengok pada note ni, do not confuse with the control system punya block diagram tu kan. Kamu ada system and then you have the kita ada controller, kita ada unity feedback dan sebagainya. So this one is the representation ataupun block diagram untuk state space. Okay. We start with, we got some integral here. Okay, kita ada integral. So notice that the input coming into this integral is going to be x dot of t. Kan, x dot of t. So bila kita integrate x dot, kita akan dapatlah x of t. Right? Okay. Refer back to this equation. So we got x dot of t is equal to ax of t plus bu of t. Kan, x dot of t equal to ax of t plus bu of t. Integral. The signal coming into this integral is x dot of t, and we integrate that signal to give us the signal of x of t. Okay. Kita ada integral, kita ada signal masuk yang mana adalah x dot of t, signal keluar adalah x of t. Right? The signal x dot of t is equal to ax plus bu of t. Kan, signal x dot of t ni, kan, first derivative of the state vector sama dengan ax, a matrix A multiply with x, ax plus b times with u. Okay, so dapatlah x dot of t sama dengan ax plus bu of t. So kadang-kadang student dia confuse juga macam mana dapat ni kan, ini sebenarnya datang daripada differential equation ni. Ini daripada equation ini kita dapatkan kita punya block diagram ni. Right. So we got x of t is our state, is the output from the integral. The input into this integral is x dot of t, and x dot of t comes from the equation of ax plus bu of t. Okay, ax, kan kat sini kan kita ada x dot of t keluar daripada summing junction ini sama dengan a darabkan dengan x of t plus with b multiply with the signal of u of t. So we got the expression for our signal x dot of t. Right. Similarly, we got the output. Okay, we got the output vector y of t. So this is our output vector y of t is simply equal to the output matrix Cx of t plus du of t. So from here you can see that y of t is equal to the matrix C multiplied with the state vector of x. Okay, y sama dengan matrix C multiplied by the state vector of x plus with d times with u of t. Okay, d times u of t. Right. So this is the representation that comes from these two equation. Daripada equation 1 dan equation 2, we get this kita panggil dia sebagai state space representation lah, block diagram of the state space representation. D feed forward matrix, C output matrix, A is a state matrix, and B is the input matrix. Right. So D, A, B, C ni apa sebenarnya? Bezakan dengan term function. Kalau term function kamu ada dalam block tu apa? It's gonna be transfer function, right? Kalau kamu consider balik block diagram, the one that you have learned previously under this topic kan, you learn about term function and then you design PI controller dan sebagainya. When you have those block, inside those block is the mathematical representation in terms of term function. Kan G of S, kemudian you have controller C of S and so on. But for this particular system, when we want to use state space representation, the one inside this block here is going to be in terms of matrix. So we got the matrix of A, we got the matrix of D, matrix of C dan juga matrix of B. So that's why dekat sini dia kata jangan confuse lah. Jangan confuse block diagram dan juga state space punya representation. Alright. Okay. So discuss ataupun to use state space equation, we have to get familiarized with a matrix punya representation lah. Kan? Maknanya you have to strengthen your knowledge on the matrix multiplication, matrix notation dan sebagainya. Right. So before we proceed to get the state space equation of a physical system ataupun from the term function to obtain the equivalent state space representation from a given term function. So let us do some review about matrices. Okay, kita review tentang matrix. The first one, square matrix. So of course, square matrix, as you can see that it will have a dimension, the row and the columns going to be the same. Kan, square matrix, number of row sama dengan number of column. Maknanya kalau kita ada matrix 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, and so on, it will have a same dimension, okay, in terms of the number of row dan juga number of column. Contohnya macam inilah. Kat sini we got the matrix of n equal to 1, implying that it's going to be 1 by 1 matrix, and this is going to be 2 by 2 matrix, and this is 3 by 3 matrix. So kalau we got a 4 by 4, maknanya dia akan jadi 4 row, 4 columns. Okay. Row, column, tahu ke? Which one is row? Ini row ke ini column?
Row dari kiri ke kanan.
Okay, row daripada kiri ke kanan, column daripada atas ke bawah. This is the first row, second row, third row. First column, second column, third column. Okay, sometimes kita confuse yang tu kan. But the notation, the standard notation is always row times column. Okay, the row times column. So ini adalah row, and then ini adalah column. Right. So when we have a square matrix, the number of row will be the same as the number of column. Okay. We also have a non-square matrix. Kan kita juga ada, kita panggil dia sebagai non-square lah. Okay, kalau atas ni square, kita ada non-square. So non-square, the number of row is not will not be the same as the number of column. So we can have a fat matrix, a fat matrix. Okay, kalau kamu ada yang ini bentuk macam ini kita panggil dia sebagai fat matrix. And then we got a tall matrix. Kan, fat matrix dan juga tall matrix. So that's why also we call it as a non-square matrix. So the example like you can see from the screen, we got A, B, C, D, E, F here. Okay. So the dimension of this matrix is going to be 2 times 3. Kan, n sama dengan 2, m sama dengan 3. The dimension of this matrix is 2 times 3. Itulah saya nak menulis tapi kalau okey kita okey, bila sampai masa untuk saya menulis, saya gunakan OneNote lah. Sebab ada setengah perkara tu kita boleh go through macam ni, and then setengah perkara tu saya suka kalau kita tulis dan kita explain dia punya secara secara step by step. Right. So this is going to be a square matrix, non-square matrix. So for this particular example, we got a 2, okay, we got 2 row multiply with a 3 column. So this is going to be 2 times 3 matrix. 2 kali 3. And then we call this as a fat matrix. So fat lah kan. Kita ada fat matrix dan kita ada tall matrix. Okay. Tall matrix mungkin dia punya 3 kali 2 dan sebagainya lah. Right. We also have we call it as a row vector. Kan? The row vector implying that we only have a single row with m number of column. Kan? Kita ada satu row saja dengan m number of column. Okay, ini adalah A, B, C, and then it has satu row dan 3 column. For this particular example, we got m equal to 3. Alright, and the last one is going to be the column vector. Column vector to imply that dia akan jadi in this form, which has n number of row with 1 column. Okay, n number of row dan juga satu kolom saja. Right, dalam paper ataupun dalam standard notation, kalau tak dimension yang itu adalah row vector, by default dia adalah column vector. Kan, kalau kamu dah buat research nanti sama master dan sebagainya, kan kena baca paper kan. By default baca paper ataupun kalau dalam matrix tu dia tak mention dia punya dimension, by default dia adalah column vector. So kebiasaannya kita akan dealing dengan column vector lah. Right. So fat matrix inilah kan kamu nampak dia dikembang itu, fat, and then tall matrix yang ABC macam ni. Right. Okay. Another type of matrix, we got null matrix. Okay, null matrix to imply that all the elements inside this matrix is simply equal to 0. Zero matrix lah ataupun null matrix. A matrix with all element equal to 0 is called the null matrix. That is all component I and J sama dengan kosong. Kamu ada matrix of zeros and then semua dalam tu adalah kosong. You might wonder why we need to use the null matrix. Of course, when we work with a complex system dan sebagainya, we are more interested to get this kind of matrix. Maknanya kita nak off diagonal. Katakan kita ada diagonal matrix, off diagonal kita suka kalau dia punya off diagonal component tu adalah null matrix. Right. So we got the null matrix. The other matrix is called as the identity matrix. So ini pun a very special matrix yang mana dalam control banyak gunalah identity matrix. A square matrix. So again a square matrix with all element 0. Kan semua elemen off diagonal ni akan kosong except those on the main diagonal are ones. Kita ada dekat diagonal ni semuanya nilainya adalah 1. Kita panggil matrix tersebut sebagai identity matrix. So this matrix is called as the identity matrix. Alright. The next one we call it as a diagonal matrix. Kan diagonal matrix as the name imply, we have all the off diagonal. Kan ini off diagonal kan. Selain daripada diagonal element ni, off diagonal dia akan jadi kosong. Only non-zero elements of a square matrix A are on the main diagonal. Kan? Kalau kita ada diagonal matrix, kita punya elemen semuanya terletak pada diagonal bagi matrix tersebut saja. Selain daripada tu, dia nilainya adalah kosong. And then the last one ataupun the other one is going to be adjoint of a matrix. Adjoint of the matrix, adjoint of a square matrix A written as ADJA. Okay, manakala kamu nampak ADJA ni is to imply that this is the adjoint of the matrix A. Is the matrix formed from the transpose of the matrix A after all elements have been replaced by their cofactors. Kita panggil matrix A, maknanya semua elemen dalam matrix A ni kan kita gantikan dengan dia punya cofactors dan kemudian kita apply transpose. Right. So apa itu pula cofactors? Okay, we go to the next slide. The cofactors, suppose that we got a matrix A like this one. Inilah kat sini dia start apa tu? Lari sikit dia punya PDF ni. So this is our matrix A. Okay, this is our matrix A. So, for example, this is our matrix A. The cofactor where were we? Okay, sekejap. Saya nak pergi balik kepada kita OneNote sebab yang PDF tu dia akan apa? Dia mungkin setting yang prepare slide tu dia apa? Dia jadikan auto advance. So, right. Okay, let's come to that. Okay, kita bekerja daripada sinilah. Okay. For the adjoint of matrix A. Okay, adjoint of the matrix A, the cofactor matrix, okay, the cofactor of the matrix A is formed by this notation. Okay, kalau kamu tengok kepada C, if you look closely, you can see that the matrix cofactor C, kan, is the determinant, kan, you got this is the apa tu? The expression of determinant. The determinant of the component of A22 times A33, kalau kamu tengok ni, basically we take this, okay, we take this as the first element for the cofactor of matrix C. Okay, the first component ataupun kan ini adalah 3 kali 3, the first row, the first element in this cofactor matrix C is taken from this part. Kita tentukan determinant, kita dapatlah matrix komponen elemen pertama pada cofactor matrix C. Right. Then, yang kedua, to fill in this cell, kan, macam mana kita nak fill in this cell ni? As you can see from here, it's going to be minus determinant of A21. A21, kemudian kat sini kita ada A23, kan, A23, A31 dan juga A33. Saya nak kamu tengok pattern tu. Cofactor yang pertama, sel yang pertama, apa yang berlaku kat sini kan? Kita nak isi yang ini. So apa yang berlaku adalah we close this and then we determine the determinant of this component. Kan, we got this matrix. Next, for this cell, kan, ataupun this unit ataupun this cell, kita boleh katakan kita tutup yang ini. Okay, you can see that we tutup yang ini. Dan kemudian you can see that we take the cofactor ataupun we take the determinant of this. Tutup ini, tutup yang ini, dan yang ini kamu hide. Right. Itulah kalau kat kelas kita boleh tunjuk dengan tangan kan. You can see that I close this one and then I close this one and then we take A21, A31, A23 dan juga A33. Kan? Tengok pattern tu. A21, A23, A31, A33. Okay? We get the determinant of this matrix. Ataupun apa tu. And then, you notice that the sign is going to be alternating. We got the first one is going to be plus, minus, and then followed by plus. So macam mana yang nak dapatkan yang ketiga ni? Yang ketiga ni, as you can see that kita ambil yang ini, kan? Kita ambil yang ini, and then we determine the determinant for this particular matrix. Okay, saya nak kamu nampak pattern tu. So bila kamu nampak pattern, kamu tak perlu hafal formula, kan? As long as you can understand the pattern on how we got this matrix, and then it's very easy. Whatever matrix given to you, as long as you get the clear understanding on how this matrix is formulated, definitely you can get the cofactor for whatever matrix given to you. Alright. Untuk yang ini, maknanya kamu kena tengok kepada setiap komponen tu. So what about this one? Same thing. What we can do is, okay, saya padam ini. Okay, untuk kamu tentukan yang ini pula what we can do is, for example, we close here, tutup yang ini. Kamu bayangkan kamu tutup ini dan kamu tutup ini, kamu tutup ini. Okay. And then we take yang ini. A12 kan, you got A12, A13, A32 dan juga A33. We get the determinant for this particular matrix. And then you notice that we should have a sign that the sign here will be alternating between plus and minus. So ini plus, ini minus, plus. Jadi kalau kamu ada 4 kali 4, 5 kali 5, dia akan alternate lah. Plus, minus, plus, minus, plus, minus dan seterusnya. Sama juga plus, minus dan seterusnya. Right. Nampak pattern tu lah? Kamu kena fahamkan dengan pattern ni. So you can see that from here we determine the determinant of A12. Okay, inilah A12, and then we got A13, A32 dan juga A33. A12, A13, A32 dan juga A33 untuk yang ini. What about this one? Okay, this one is we got it from here. Kan, kamu bayangkan kita tutup yang ini, kemudian kita tutup ini, kita tutup yang ini. And then we got it's going to be A11, kan, kita ada A11, A13, and then we got A31, A33. Kan, kita ada A11, A13, A31 dan juga A33. A11, A13, A31 dan juga A33, dan we compute the determinant for this particular matrix. And then the next one for this cell, kan, sel yang ini pula, we do the same thing. You can imagine that kita tutup yang ini, dan kita tutup yang ini, dan kamu ambil yang the rest of this value ni, kan. Kita ada A11, kita ada A11, saya besarkan sikit. Okay. Kita akan ada A11 kan, kita ada A11, A11, A12, A31 dan juga A32. So we got this value untuk sel yang ini. Right. What about this one? Sama lah, konsep yang sama. What we can do is, let me erase this first. Okay. What we can do is, kamu tutup yang ini, kan? Kamu bayangkan you want to get what is the cofactor for this cell ataupun, jadi kita akan tutup yang ini. So you bayangkan kita tutup macam ini. So we got A12 kan, A12, A13, A22 dan juga A23, and we compute the determinant for this particular matrix. Okay. Untuk sel yang ini kan, untuk yang ini, jadi kita kira ataupun kita dapatkan determinant of A12, A13, A22 dan juga A23. Right. Next, what about this one? Same thing kan, bila kita nak dapatkan the cofactor here, what we can do is we tutup sini. Okay, we tutup sini. And you can see that it's going to be A11, A13, A21, and A23. And again, you must be careful with the alternating plus and minus sign here. So we got plus, minus, and you have to carry on with the alternating plus and minus sign here. Right. So that's how we construct the cofactor of the matrix A. So this is the matrix A. We got its cofactor. The adjoint of this matrix is simply we apply transpose of the cofactor matrix. Once we got this cofactor matrix, to get the adjoint of the matrix A, what we have to do is we simply apply transpose of the matrix C. Transpose tu apa? Transpose tu maknanya kalau kita ada matrix tu, kita transposekan dia akan jadi row kolom, row akan menjadi kolom dan sebagainya lah. Transpose. Ya, saya rasa macam ada dalam nota tadi. Right. Okay, again, you can stop me anytime and you can ask me question at any point of time. No need to wait sampai ujung dan sebagainya. Kalau tak faham, boleh terus angkat tangan dan tanyalah. Ataupun you interrupt saya terus pun tak apa. The beauty using MS Team ni, dia ada reaction kan, you boleh angkat tangan dan you boleh you boleh tanya soalan dan sebagainya lah. Okay, so that is the adjoint of the matrix A. Right, let's move on. Okay, so itu saya rasa macam ada tadi. Okay, so this is the transpose of the matrix. transpose matrix. The transpose of the matrix A designated as A transpose. Kan whenever you see AT dekat atas ni, itu imply that this is going to be the transpose of the matrix A. Okay, the transpose of the matrix A is formed by interchanging the rows and column of A. Thus, if A is an n by m matrix with element of A ij, the transpose is m by n matrix with the element of A ji. Okay. Maknanya kalau kita ada transpose of the matrix A, kalau sebelum tu kita matrix A adalah kan, katakan kita ada matrix A, the size of the matrix A is 3 by 2. Kan matrix A dia punya dimension dia adalah 3 kali 2. So if we were to get the A transpose, what will happen is the size of the matrix A now becomes 2 times 3. Kan katakan kita ada matrix A sama dengan A 3 kali 2 kan, A, B, C, D, E, F. Kan ini adalah kita punya matrix A, 3 kali 2 kan, 3 kali 2, 3 kolom, 2 row. 3 kolom, 2 row. Dan kalau kita nak transposekan dia, maka dia akan jadi, kolom akan jadi row, maka kita akan dapat A, B, C, D, E, F. Okay. Note the difference. Okay. Ini adalah matrix A. Size bagi matrix A adalah 3 kali 2. Dan size bagi A transpose dia akan jadi, dia terbaliklah 2 kali 3. Contoh je kat sini, kita ada matrix A sama dengan A, B, C, D, E, F. Dan transpose of this particular matrix, kamu akan nampak ini A, B ni, dia akan jadi A, B, C, D dan juga E, F. Right. So that is transpose of a matrix. So of course some of the properties of the matrix transposition yang selalu kita akan tengok ataupun guna pakai yang ni lah. If we have a two matrix, A times B transpose is just the same as we transpose A and then we multiply with the B transpose. Kan kita ada A darabkan dengan B transpose, nilai dia dia akan sama dengan nilai A transpose darabkan dengan B transpose. A transpose dulu darabkan dengan B yang kita transpose dulu. Right. Same thing if we got A, B, C, kan, if we got 3 matrices, matrix A, matrix B and matrix C. Multiplication of matrix A multiply with matrix B, multiply with matrix C, and then we transpose. The effect is just the same as we transpose first matrix A, and then we transpose matrix B, we transpose matrix C, we multiply the transposition of matrix A transpose, B transpose dan juga C transpose. Itu adalah dia punya property lah. Kan? Maknanya kalau bila kita nak buat derivation dan sebagainya, there will be a certain point you want to provide a proof in your mathematical expression. So you have to understand on the some property of the matrix transposition. Boleh kan?
Boleh, sir.
Right. The challenging of online learning is we cannot see the faces of the student. I cannot see the face of the student lah. Tak nampak muka kan, you off camera. So kalau you on camera, dia akan menyebabkan lagging kan. So the same thing happened to my student because some of them using data dan sebagainya. Kalau dia kata on camera, dia akan jadi lagging. Nampak masalah internet connection lah kita punya negara ni kan. Itulah. Tak boleh komen lebih-lebih, benda rekod kan. Right, tapi the issue is we are still lagging behind other countries lah in terms of internet speed connection dan sebagainya lah. Right, so you know who to vote for the upcoming election. Right. Okay, so that is the property of the matrix transposition, matrix operation. So let's move on to another component, the operation of the matrix. Kita belum masuk lagi state space lah. Kita baru buat revision of the matrix punya operation. Kelas kita sampai pukul 10 kan, Dr. Rajidah? 10. Saya rasa macam pukul 10 kan? Dia orang ada kelas lain lah kan? Betul?
Tak ada. Hari ni sebab kita kat PKA memang tak ada kelas pada hari Jumaat. Jumaat memang kosong.
Okey, Jumaat memang kosong. Okey.
Nanti 9:30 boleh break Dr. Syakirin. After 1 hour lecture boleh break 10 minit and then boleh continue sampai 10:30.
tak possible kot sebab sebenarnya saya ada seminar untuk final
Okey, tak apa, tak
diploma.
apa. Boleh.
Sampai
Boleh sampai
10
Dr. Syakir punya masa. Boleh.
Okay, alright. Okay. Itulah dia, we are in the week 14. So in the week 14 we have assessment lah kan, assessment untuk final year project on the last Wednesday, and yesterday was for the engineering tech punya program. So hari ni untuk diploma punya program. So I'm also one of the panel untuk evaluate. So agak itulah, saya mula-mula saya ingatkan semalam untuk diploma tu yang jadi dia perubahan jarum waktu agak kabut sikit. Right. Okay, let's move on to understand about the matrix operation. So I believe that most of you have learned this in your matriculation dulu kan. Okay, macam mana nak tambah matrix, how to subtract between two matrices. So suppose that we got matrix A and matrix B. So this is our matrix A and this is matrix B. Okay, A is 1, 2, 3, 4 plus and B is 5, 6, 7, 8. And if we were to multiply to add between these two matrix A plus B is simply we add them element by element, component by component. So if we have this gonna be 1 is the matrix of A11. Okay, the component let's denote it as the matrix A11 kan, ataupun A11, and this is gonna be A12, A21, and we have here A22 untuk matrix A kan, ini adalah matrix A. And then let's say we got our matrix B is equal to P11 kan, dia akan jadi B11, B12, B21 dan B22. Baik. So ini adalah BA21 lah. Okay, ini adalah A21. A21 and this is going to be A22. If we were to add these two matrix A plus B, very straightforward to imply that we add them element by element. So the resultant of the addition between these two matrices we got is going to be A11 plus B11, and here we got A12 plus B12. Okay, and here we got is going to be A21 plus B21, and this is going to be A22 plus B22. Right. Okay, very straightforward, as simple as that. Right. Same thing, if we were to subtract between matrix A and matrix B, we also do the same operation, A minus B. Here we got A plus B. We will be subtracting them element by element. But you have to be very careful on the dimension ataupun size for the matrix. We can only add them if they are the same size. Kan dimension sama, then barulah kita boleh tambah dua tu lah. Kalau dimension tak sama, macam mana tambahkan? 3 kali 2 dengan tambahkan dengan 5 kali 6. So you have to, the matrix addition and subtraction is only possible if we have both of them are in the same size, of the same size. Right. So that is the matrix addition dan juga subtraction. Right. The next one is going to be the matrix multiplication. So this is going to be a matrix A. So let's suppose that we got a matrix A multiply some vector, kan ini adalah vector X dan juga Y. So the resultant ataupun the result of the multiplication is going to be AX plus BY. A darabkan dengan X, kan kita, kalau untuk matrix maknanya A ni darabkan dengan X tambahkan dengan B darabkan dengan Y. Ini kan, maknanya A darabkan dengan X, you got AX plus with B darabkan dengan Y. Sama juga for the second row, we got C multiply by X tambahkan dengan D multiply by Y. Okay, so do not confuse between matrix addition, subtraction with multiplication. So multiplication you have to multiply by element juga kan, tapi it's gonna be AX, A multiply with X plus with B multiply with Y. Right. So notice that the dimension for this particular multiplication, here we got 2 by 2, multiply with 2 by 1, and the result is going to be 2 by 1. So macam mana kita nak tahu dia punya dimension ataupun size untuk hasil multiplication? It's gonna be yang inilah, kita tengok pada nombor yang pertama ni dan juga nombor yang hujung ni. Okay, ini adalah matrix 2 kali 2 multiply with 2 kali 1. The result is gonna be 2 kali 1. Okay, 2 kali 1. And you have to make sure that you have to ensure that this is the same size. Kan 2 ni barulah dia boleh multiply. Kalau you nak multiply with a different dimension, you will not be able to do multiplication. If you do multiplication in the MATLAB, it will give you some syntax error lah. Kalau kamu gunakan MATLAB nak buat multiplication, kamu akan dapat syntax error. Right. Multiplication is not by element. It's not by element. Product of 1 by n matrix and a n by 1 matrix is scalar. Kan 1 kali n. Produk bagi 1 kali n dan n kali 1 adalah skalar. Maknanya katakan kamu ada satu row vektor kan, darabkan dengan kolom vektor. Katakan saya letak value 2, 3, darabkan dengan 4, 5. So, ini adalah vektor kan, ini adalah 1 kali 2. Yang ini pula 2 kali 1. Hasil darab dia what we get is going to be 2 times 4 is 8. 2 times 4 plus with 3 times 5. And we will have, this is going to be 8 plus 15. Okay, 15 campurkan dengan 8. Apa tu? Sengak. 15 campur 8, 20. 15 campur 8. 23. Okay. So you can see that 23 is a scalar value, it's scalar quantity. Kan? Scalar. Maknanya you got a matrix 1 by 2 times 2 by 1 is a matrix ataupun vector, and then the result is going to be scalar. Right, product of n by 1 matrix and 1 by n matrix is n by n matrix. Maknanya kita tengok ke ujung ni lah kan. Kalau kita ada n kali 1 darabkan dengan 1 kali n, maka kita akan dapatlah n kali n punya matrix. Right. So that is the matrix operation. Okay. So matrix operation, matrix multiplication. So we got A, B, C. Okay. Matrix A, B, C. Ini adalah 1 kali 3 punya matrix. Darabkan dengan X, Y, Z. Ini juga adalah 3 kali 1. Is vector of 3 by 1. And then we got the result is going to be AX plus BY plus CZ, which is a scalar value lah. Kita akan dapat scalar. Right. And if we were to multiply, for example, we got X, Y, Z. This is a 3 by 1 matrix. Multiply with A, B, C. This is 1 by 3 matrix. And the resultant is going to be 3 by 3. So kita akan dapatlah 3 kali 3. Kan dimension ini adalah 3 kali 1, 3 row. Kan untuk matrix ini we got 3 rows, 3 rows 1 kolom. 3 rows 1 kolom, ini adalah 1 kolom 3 row. Sorry, 1 row 3 kolom. Ini adalah 3 row 1 kolom. Ya, ini adalah 1 row 3 kolom. So result dia kita akan dapatlah matrix with 3 by 3 matrix. Right. So in general, matrix A times B tak sama dengan B times A. Secara general tak sama lah. Dia kena tengok kepada selection of value of A dan juga B. To multiply any two matrix, they have to be compatible. To get AB, the number of column of A must be equal to the number of rows. For example, A adalah K by N, B adalah N by M. So inilah macam saya beritahu tadi. Maknanya if we were to multiply between two matrix, we have to be very careful on the dimension of the matrix. We cannot simply multiply if they are not the same in terms of apa tu yang kat tengah ni kan. K kali N darabkan dengan N kali M tu. N tu kena samalah N kali kalau katakan kita ada matrix A, kan kita ada matrix A dimensionnya adalah 2 kali 3. Jadi kita boleh darabkan dengan katakan matrix B adalah 3 kali 2. Kita nak buat operation A darabkan dengan B. maka kita akan dapatlah dia punya dimension dia akan jadi 2 kali 2 kan. Sebabnya ini adalah 2 dan ini adalah 2. So kita akan dapatlah 2 kan 2. Dan katakan kita ada matriks C, dan matriks C dimension dia adalah 4 kali 3. Kan 4 kali 3. Jadi kalau kita nak darabkan A darabkan dengan C, kita tak akan dapat lah. Kan sebab apa tak dapat? Ini 2 kali 3. 2 kali 3 darabkan dengan 4 kali 3, the dimension is not compatible. So when the dimension is not compatible, you cannot do the multiplication. Baik. You faham ke set ni?
Faham, sir?
Alright, good. Okay, R tu maksudnya apa? Real vector kan? Real punya vector. Real matrix. A set of real vector, set of real matrix. Alright, let's take a look at this example. Okay, ini pun kita nak kena tunjuk ke? Saya rasa very straightforward kan? Maknanya kalau kita nak buat operation matrix A plus matrix B, A tambah B is very straightforward punya operation. Because A plus with B, we have to add them element by element. Same thing if we were to multiply B tambahkan dengan A transpose, B tambahkan dengan A transpose, maknanya we have to transpose A and then we multiply with, we add them with B. So tengoklah satu kan. Okay, katakan we want to do the operation of B plus A transpose, B plus A transpose. We know that our matrix B is 4, 5, 7, 9. Okay. Plus with A transpose, we have our A is minus 3, 1, minus 2, and 0. We transpose the matrix of A, we will get this is going to be minus 3, 1, minus 2, and 0. Okay. So this is the transpose of the matrix A, and then we can add them element by element. So we got 4 plus minus 3 is 1, 5 plus minus 2 is 3, 7 plus 1 is 8, 9 plus 0 is 9. So this is the result of addition between this A plus A transpose. So the rest I believe that you can do that on your own lah. And maknanya very straightforward, tambahkan element by element. Right. Okay, let's move on to the next example. We got a multiplication between, we got matrix A is given by, 2, 3, 4, 5. B is A, 3, 5, 2, 4, 8. C is 4 minus 5. So of course, in terms of dimension, you can see that the matrix A is 2 by 2. Matrix B is 2 by 3. And matrix C is 2 by 1. Dan in terms of dimension kan, ini adalah 2 kali 2, ini adalah matrix 2 kali 3, C adalah matrix 2 kali 1. Okay, 2 kali 1. Ataupun kadang-kadang we can, if we have a column vector, kan, if we have a column vector, you can simply write it like this one. Tak perlu ada 2 kali 1 tu. Kan, kamu just tuliskan dia sebagai R2. Okay, R2. Kan nanti kalau kamu buat master, buat study PhD, baca paper, research paper lah, bila baca research paper dia suka guna notation macam ni. Jadi tu saya nak introduce kamu kepada all this notation lah. Dan saya believe kamu dah belajar pun dalam subjek lain tu. Okay, let's take a look on one of the example. If we were to multiply, okay, 15A, what will happen if we multiply a scalar? Kan, kita ada 15 is a scalar value, multiply with a matrix. Kan, katakan kita ada 15 darabkan dengan matrix A. So A is 2, 3, 4, 5. What will happen to the resultant of the multiplication between a scalar value with a matrix? Kan, 15 itu scalar value kan, darabkan dengan matrix A. Apa yang berlaku adalah kita akan darabkan setiap elemen dalam matrix A ni by 50. So we got 2 times 50 is 30, 3 times 15 is 45. Okay. 4 times 15 berapa? 15 kali 4, 20, 60 kan? 60. Dan 15 kali 5. Saya CP dah apa ni kan. So berapa tu? 15 kali 5 we got
75.
75. Alright. Tua-tua ni kan, VCP pun nak congak tu kadang-kadang dia especially kalau you selalu gunakan MATLAB dan sebagainya kan, and then you sometimes the simplest mathematics you feel lazy to think to do the calculation in your head. Right, it happened over time. It happened to me. Right. So what always happen is when we multiply with kita ada a constant k multiply with a, what is happening is we simply multiply all the element here by 50. Right. So let's take another example. Katakan kita ada C, okay, AC lah. So we got A multiply with C. So let's say we have AC, A multiply with C. Okay. So this is going to be simply equal to matrix A. We got 2, 3, and 4, 5. Okay, I purposely take the simple example. And C is 4 minus 5. 4 minus 5. Kan A, we got matrix A multiply with matrix C, and the resultant ataupun the result of the operation we got 2 times 4 plus with 3 times minus 5. Okay, 2 darabkan dengan 4. So kita ada 2 ni darabkan dengan 4, tambahkan dengan 3 darabkan dengan negatif 5. And then we have another one is going to be 4 times 4. Kan 4 times with 4 plus with 5 times minus 5. Okay, 5 times minus 5. So ini kita dapatlah 8 tambahkan dengan negatif 15. And then kita dapat ini adalah 16 tambahkan dengan negatif 25. So ditekanlah sendiri apa kan dia punya ni. You got the resultant of the operation between matrix A multiply with C. You have to write until your final answer. Do not leave macam plus saya buat ni. So you got this is going to be some value here and this is going to be another value here. Right. Always I tell my student, only me are allowed to use this kind of answer. Kan, maknanya saya beritahu student saya saja yang boleh bagi jawapan macam ni lah. Maksudnya janganlah kamu buat jawapan macam ni kan. Nanti dalam test kamu bagi jawapan bulat-bulat macam ni. And then you have to put the values inside this matrix operation. Okay, so that's how we do matrix multiplication. So the rest, I believe you can do that on your own. Right. Okay, let's take a look at this example. How to show that A plus BC transpose sama dengan A transpose plus BC transpose. Bagi idea sikit. Macam mana kita nak tunjukkan yang ini sama dengan yang ini? How can we show that this A plus BC transpose is the same as A transpose plus BC transpose? What is the step that we have to do to show? Kan soalan kata show kan, tunjukkan yang ini sama dengan yang ini. Any wild guess on how can we show A plus BC transpose is equal to A transpose plus BC transpose? Macam mana? Ada idea? Okay. Macam mana kamu nak tunjukkan sesuatu perkara sama dengan sesuatu perkara? Maknanya kena kira lah kan? Okay, what you have to do is you have to compute on the left side of the equation. So you have to compute A plus BC transpose. Okay, you have to get your matrix A plus with the matrix B times C, and then you transpose everything. And then once you do the operation on the left side of the equation, you got the result ataupun you got the value, and then you do the same thing on the right hand side using the same expression. Kan, you got A transpose. Mana kamu transpose dulu A transpose ni, tambahkan dengan BC, B multiply with C, and then you transpose. If you are able to show that the value ataupun the matrix on the left is the same as the matrix on the right, and then you can show that this equation is sama lah. Itu maksud dia. Ya, kamu nak tunjukkan this equation is the same as this one. You have to substitute. You have to perform operation according to given equation expression kan. Kamu ada A plus B, C. So you have to got A plus B times C. Buat operation tu dulu. You transposekan dulu. Dapat some matrix. And then you do, you dapat the result of the operation on the left hand side of the equation. And then you do the operation on the right hand side of the equation. If you are able to show that they got the same value. And then it is shown that A transpose, A plus BC transpose is equal to A transpose plus BC transpose. Macam itulah kita nak tunjukkan sesuatu perkara sama dengan suatu perkara, kita kena selesaikan cara A, kemudian selesaikan cara B. So kalau cara A sama dengan cara B, dapat sama, maknanya samalah dia punya expression tu. Right, so saya tak nak buat lah sebabnya panjang kan. Shall we take a break? 5 minit ke macam mana? Boleh 5 minit ya?
Boleh, sir.
Boleh 5 minit Kita
Boleh.
toilet break sekejap. Alright. Kita berhenti 5 minit dan kemudian 9.40 kita sambung balik and then sampai pukul 10 boleh Okay, kita break ya. Okey. Boleh ya? Boleh saya sambung ke?
Boleh.
Boleh. Alright.
Boleh sir.
Okay, kita dah tengok kepada kita punya example, okay, the operation of the simple mathematical operation involving the matrix. Now we try to understand about the another components, a very critical ataupun important component in the matrix operation. Okay, we call it as the determinant. Okay, determinant. Okay, kita panggil dia sebagai determinant. Right, determinant are defined for square matrix only. Okay. If you have a non-square matrix, you cannot find the determinant. Okay, determinant hanya wujud pada square matrix saja. Okay, the determinant of the n by n matrix A written as palang 2 ni, okay, absolute value of A kan, ini adalah notation for determinant. Okay, is a scalar valued function of A. Okay, what will happen is when we perform the operation of computing the determinant, we will get a scalar value. Okay, kita akan dapat scalar value. The family form of the determinant for n equal to 1, 2, 3 and so on. Okay. Okay, katakan kita ada n equals to 1. So n 1 by 1 punya matrix. Okay. We have a determinant of A is simply the A11 lah kan. Katakan kita ada satu determinant of A. Matrix A only have a one value. So we got the determinant of the matrix A is just simply equal to that A11. Right. Suppose that we have the matrix A is a 2 by 2 matrix. Kan, katakan kita ada matrix A is a 2 by 2 matrix. So again, sometimes student is always confused between matrix dan juga determinant. So matrix, we got a matrix A is defined by you have a square bracket. Kan, square bracket ni adalah matrix A. A11, A12, okay, A21, A22. So this is a matrix A. Dia adalah matrix. If we were to talk about determinant of the matrix A, to imply that this is the symbol of the matrix A, and the expression of the matrix A, we have to use this gonna be A11, A12, A21, A22. Okay. Note the difference between matrix A and the determinant of the matrix A. Ini adalah matrix. Matrix A, we use the square bracket. And then we have the determinant of A. This is a mathematical expression whereby we need to find the determinant of the matrix A. And for this particular example, this is simply equal to A11, A11, A22 tolakkan dengan A12, A21. Right. But ini student saya lah. What happen is when they write determinant, okay, instead of writing in this form, they write as a square matrix macam ni. So menunjukkan tak faham lah. Okay, bila tak faham tu kena explain lebih sikit untuk kamu fahamkan perbezaan antara matrix dan juga determinant. Kan? So ini adalah matrix. The notation of the matrix we use the square bracket, and determinant we use the straight line to denote the determinant of the matrix of A. Right. So do not confuse between determinant dan juga matrix. Okay. So what about if we have 3 by 3 or 4 by 4 or 5 by 5 matrix? How can we compute the determinant of the matrix A? For the case of 2 by 2 is very straightforward. Kan, untuk kita kira matrix 2 kali 2 to get the determinant of 2 by 2, what is happening? We will multiply A11 multiply with A22 minus with A12 multiply with A21. Kan, A11 darab A22 minus with kita silang yang ni kan, A12 darabkan dengan A21. So for the case of 2 by 2 matrix, very straightforward for us to compute the determinant of the matrix A. What about if we have a higher dimension? 3 by 3, 4 by 4, 5 by 5 and so on. And then the approach ataupun the method of for us to find the determinant will be slightly different. Right. So let's try to understand on how can we compute the determinant for a 3 by 3 case. Okay, we got a 3 by 3 case. So there are several methods. Kan, ada beberapa cara untuk kita kira determinant.
as given in the slide ni. The first one, we can compute the determinant of the matrix A simply by, okay, dia tulis macam ni kan. Alright. So we can compute the determinant of the matrix A is equal to, okay. So we take A11, kita akan ambil A11. So note the first element here, A11, and then we take determinant of apa dia panggil, cofactor ke apa? Okay. We find the determinant of A22, A23, A32 and A33. Kan? Kalau kamu tengok daripada ni, kita ambil determinant yang ini. Ataupun you can see that kita tutup yang ini dan tutup yang ini. And then we get the determinant of A22, A23 and A32, A33. So since here we got only a 2 by 2 punya matrix, it's very straightforward for us to compute the determinant of this matrix. Right? And then minus with, kan kita boleh ambil yang ini pula. Kan kita ambil yang ini, kan ataupun kita tutup yang ini, tutup yang ini, tutup yang ini. Minus with A12, okay, and then we get the determinant, kita ambil yang ini, A21, kan kita ambil A21, A31, A21, A31, and then we got here A23 dan juga A33. A23 dan kita ada A33. So we find the determinant of this 2 by 2 matrix. Kan kita nak cari determinant of matrix A. Matrix A, the dimension of the matrix A is a 3 by 3. Okay, the way we get ataupun the way we compute for the determinant of the matrix A is kita ambil yang ini yang pertama tu A11, and then we find the determinant of is a cofactor ke panggil. Okay, A22, A23, A32. Maknanya you take this one. Okay, you can imagine that we close ataupun kita tutup yang ini, kan tutup yang ini, yang ambil matrix ni. Minus with, tutup A12, we got A12, kita ambil yang ini. Kan kita ambil yang ini. Dan kita tutup yang ini, kita tutup yang ini. So we got A21, kamu akan ada A21, A23, A31 dan juga A33. And plus with, kita tutup yang ini, A13, kita tutup yang ini dan kita tutup yang ini. To imply that it's going to be A13, and then we find the determinant for A21, kan kita ambil A21, A21, A22, A31, A22, A31 dan juga A32. Right, that is one way of finding determinant of the matrix A. Right, so yang ini pun sebenarnya kalau kamu tengok pada persamaan ini datangnya daripada yang atas ni lah, datang daripada yang atas ni. Tapi sebenarnya cara yang didapat equation yang bawah ni, kita ambil A11 and then kita akan dapatkan determinant for this cofactor, dan kemudian kita ada A12 dapatkan, kita bayangkan tutup ini and then kita dapatkan determinant of 2 by 2 matrix, and then kita ambil A13, tutup ini, and then kita dapatkan determinant of this matrix. And then we get the determinant for matrix A. The size dimension of the matrix A is a 3 by 3. Right. That is one method of finding determinant. Another method, kan method yang kedua. Another method, what we have to do is you simply repeat, kan? Kita ambil the first two column, kan? Kita ada A, B, C, D, E, F, G, H, I. Dan kemudian kita rewrite, ambillah first two column yang kedua ni. Kita tulis sebelah kanan dia. Tulis kat sebelah sini. Kan? Tulis kat sebelah sini. And then, kita darab silang lah. Okay, we got A darabkan dengan E, darabkan dengan I. Pluskan B, darabkan dengan C. Let me use another color to avoid confusion. We got A darab E, darabkan dengan I kan? We got A darab E, darabkan dengan I. Tambahkan dengan B, darabkan dengan F, darabkan dengan G. Dan kemudian kamu akan ada C darabkan dengan H, darabkan dengan C darab D multiply by H. C times D times H. Right? You take the diagonal punya value here, A darabkan dengan E, A multiply with E multiply with I, plus with B multiply with F multiply with G, plus with C multiply with D multiply with H. Right. Then you minus with, kita ambil yang off diagonal ni pula. Kan? Kita ada, we got C multiply with A multiply with G, minus with A multiply with F multiply with H, minus with B multiply with D multiply with I. Right? Very straightforward kan? Maknanya yang atas tu you have to compute the determinant of the cofactor tu. But the second method, you simply repeat the first two column and then you sum up the multiplication of the off diagonal. But you have to use only the one that with a size of 3 lah. Kan? Ini ada 3 multiplication A, E darabkan dengan I. What about A, E here? Do we need to take that to take the multiplication of A, E into consideration? Kan? Yang ini kan? Boleh ambil ke tak ambil? Sebenarnya boleh ambil tapi dia darab dengan kosong lah ujung tu. Okay, so we can already omit that from our derivation. Right. Okay, so that is the second method. Okay, second method, mana you repeat the first two column, you put it on the right hand side ataupun on the right of your original matrix, and then you multiply it diagonally according to this order. Right. The next method, the next approach ataupun method yang ketiga for us to compute determinant, you repeat the first two row. Tadi kita repeat the first two column, kan? We repeat the first two column. The next approach is by repeating the next two row. Repeat the first two row. So this is the first row, this is the second row. So we take this first two row and then you write it at the bottom of your original matrix. Kan? We got A, B, C, D, E, F, G, H, I. That is your original matrix. And then you repeat the first two row and you write it down there, kan, bawah ni. So this is the first two row that you take from your original matrix. And then kita boleh multiply lah to get the determinant of this matrix. You can multiply A, you can see from here A, E, I, kan, multiply yang ini. Kan ada A darabkan dengan E darabkan dengan I, plus with D darabkan dengan H darabkan dengan C, plus with G darabkan dengan B darabkan dengan F. Kan? A darabkan dengan E darabkan dengan I, plus with D darabkan dengan H darabkan dengan C, plus with G times B times F, minus with, and then you have to take in this direction, C darabkan dengan E darabkan dengan G, GEC, minus with F, H, A, and we got I, B, and D. I times B times D. I, B, D, D, B, I is just the same value. Right. So these are the three methods that you can use to compute the determinant for 3 by 3 matrix. So I believe I'm not sure lah, mungkin kena tahu semua ke ataupun you just understand ataupun you just master one of the method to compute determinant, that should be sufficient. Right. Kena tanya balik atau tidak lah, kena guna tiga-tiga ke ataupun fahamkan satu saja ke. So if you understand all three of them, and then it should be good for you lah. Right.
Pilih satu method saja.
Pilih satu method saja. Alright. So you can you can choose any of the method that you feel comfortable for you to compute the determinant. Right. So how can we compute for the determinant of this particular example? Okay, so ini adalah 3 kali 3, 4 kali 2 kali 2, 3 kali 3 dan right. So we got the first one is in terms of all the real vectors, and the other one we got example in terms of S domain ni kan. So basically they are the same approach for us to find the determinant of the matrix. Okay. Let's say we want to find the determinant for the matrix D. How can we compute the determinant of the matrix D? Okay, let's try to do this example. Saya rasa yang untuk real value ni tak ada masalah lah sebabnya dia very straightforward kan. Part 3, 1, 2, I believe that you can do that on your own. But maybe when you have a S variable, Laplace punya representation, how can we compute the determinant for this particular system ataupun for this particular matrix D. Right, let's take a look at the example D here. We got our matrix D is equal to S2, S plus 3, and S plus 1. Okay, S plus 3, S plus 1. And we want to compute for the determinant of the matrix D. Okay, in order to compute, we know that since it is a 2 by 2 matrix, the same concept apply even though we have S in our matrix. Konsep yang sama masih lagi diguna pakai, whereby we can compute the determinant of the matrix D is simply the multiplication of S darabkan dengan yang ini S darabkan dengan S plus 1 minus with 2 darabkan dengan S plus 3. Okay, S here come from here. Okay, we got S multiply with S plus 1 minus with 2 times S plus 3. And of course, you have to expand this. Do not leave like that. You have to expand this. So it's going to be S squared plus S minus 2S minus 6. And then you will have your determinant of the matrix D is simply equal to S squared minus S minus 6. Okay, the same operation, the same concept for us to compute for the determinant, even though we got S in our element. Right, so that is the example of D. What about example E? So now we have a 3 by 3 matrix. How can we compute for the determinant of the matrix E ni? Okay, we want to compute the determinant of the matrix E, which is simply equal to, macam mana kita nak kira determinant of the matrix E? First, we take the element, first cell ni kita ada S kan? We got S. And then we have to multiply with this, kita tutup yang ini, and then kita ambil yang ini. So we find the determinant of 0, 4, S plus 6, and 1. Faham konsep ni? Maknanya if we want to compute for the determinant of 3 by 3 matrix, we take this yang ini, which is S, and then we compute for the cofactor here. It's going to be a determinant of the cofactor as 0, 4, S plus 6, and 1. 0, 4, S plus 6, and 1. And then minus with, minus with 1. Kita ada minus with 1. And then we find the determinant, tutup yang ini. We find the determinant for S plus 2. And here we got 4. This is 1 and this is 1. Plus if, again, you have to remember we have to alternate. First we got plus, minus, and then the other one is going to be plus. Plus with 0, plus with 0, kita ada 0 dekat sini. And then we get the determinant, tutup yang ini. So we got the determinant of S plus 2, 0, 1, S plus 6. Okay, and then when we want to compute for the determinant of the matrix E, we simply get is going to be equal to, we got S multiply with, so 2 by 2 matrix is very easy to get the determinant of 2 by 2 matrix. For this particular example, we got 0 darab dengan 1, which is 0. 0 minus with 4 times S plus 6 is going to be minus 4 S plus 6. And then here, we will get it's going to be minus 1, and we got this is S plus 2. S plus 2 plus times with 1, which is S plus 2. So we got S plus 2 times 1 minus with 1 times 4, which is 4. Okay. And then plus with 0 multiplied by this determinant is simply give us 0. Ini kita dapat kosong je lah. Right. And then we can expand it such that we will get is going to be equal to, so kamu boleh expand lah kamu punya expression. We got S, this is going to be minus 4S minus 6 dapat 24 24. And then here we got this going to be minus apa tu? S kan kita ada kat sini kan. So we got minus S minus 2 2 minus 4 is minus 2. Minus going to be plus 2. Okay, plus 2. And then this is going to be minus 4s square minus 24s minus s plus 2. And in the end, we will get our determinant is simply equal to minus 4s square minus 24 minus s is we got minus 25s plus with 2. So this is how we compute for the determinant of the matrix E. Okay, itu cara untuk kita dapatkan determinant untuk matrix E. Right, crystal clear on this part. Very straightforward. And then I believe you can do the same thing for this apa tu matrix F ni. Since you got a 0 here, so it's very interesting lah. Kan 0 darab dengan all the determinant, it just simply give you 0. But you have to be very careful between the sign. Kan plus minus, make sure kamu follow dia punya apa tu alternating sign tu. Right. So the last one, boleh satu lagi yang matrix inversion ni. And then lepas tu saya kena stop lah kot. Boleh Tuan Jidah?
Boleh. Nanti saya take over.
Yeah. Alright. Okay, the last one. We got the determinant. We learn about how can we find the determinant of a given matrix. And the next one, we want to find the inverse of the matrix. Kita nak dapatkan matrix inverse. So why we need to get apa tu? Kita nak kena fahamkan berkenaan dengan matrix inverse. Of course sebabnya nanti dalam design controller dan sebagainya banyak gunakan inverse matrix ni. Okay, we use a lot matrix inversion in our calculation. Right. N by N square matrix. So the matrix inverse only exists for a square matrix. Kan kalau dia tidak square matrix, kalau matrix tu tidak square, kan bukannya square matrix, dia ada juga inverse tapi kita panggil dia sebagai pseudo inverse. Okay, pseudo inverse. This macam dummy punya inverse lah. Right. So the matrix inversion only exists for a square matrix. Okay. For n by n square matrix A has an inverse denoted by A inverse. Kan A to the power of minus 1 ni kan ini sebenarnya bukan kuasa negatif 1. But this is the notation to imply that this is the inverse of the matrix A. Okay, inverse of the matrix A. Whereby it must satisfy A multiply with its inverse to give us identity matrix. Matrix A darabkan dengan dia punya inverse, kita akan dapatlah dia punya identity matrix. Always this situation ataupun this condition must be satisfied. A darabkan dengan A inverse give us identity matrix. So we got I is the n by n identity matrix. Apa dia identity matrix ni? Identity matrix adalah all the diagonal element of that matrix is equal to 1 kan? Katakan kita ada I2. Kadang-kadang notation kita buat macam ni, I2 matrix maknanya kita ada 2 kali 2 punya matrix. Ini adalah identity matrix. All the diagonal adalah apa tu? 1. Elemennya adalah 1. Kan ini adalah identity matrix of 2 by 2 matrix. So the inverse of the matrix A, kan untuk kita dapatkan inverse bagi matrix A adalah we have to find the adjoint of the matrix A divide by the determinant of the matrix A. Inverse bagi matrix adalah adjoint of the matrix A and then kita kena bahagikan dengan determinant of the matrix A. So that's why we do the revision on how to get the adjoint of the matrix A as well as on how to get the determinant of the matrix. We need to use these two information to compute for the inverse of the matrix A. Kamu nak kena faham macam mana nak cari adjoint matrix A. Kan? Macam mana tadi adjoint matrix A? Like atas tu. Kita recall balik ke atas. Adjoint. Okay, sekejap. Okay, ini kan. So you must be able to get the adjoint of the matrix A. So once you get the adjoint of the matrix A, you must know on how to obtain the determinant of the matrix A. Because once we got these two information, adjoint of the matrix A as well as the determinant of the matrix A, and then we can compute for the inverse of the matrix A. Tahu adjoint, tahu dia punya determinant, and then kita boleh kira dia punya inverse of the matrix. Right. So the inverse of the matrix A, by the formula given in the slide, is simply equal to the adjoint of A and divide by the determinant of A. Balik. A. So the inverse of the matrix A is simply equal to adjoint of the matrix A divided by the determinant of the matrix A. So kena faham lah, because this knowledge, kan, pemahaman kepada macam mana nak cari inverse tu penting lah. Sebab nanti bila kita nak convert daripada state space pergi kepada transfer function, kita banyak gunakan inverse ni. Kan, daripada state space nak dapatkan transfer function. Kan, tadi kamu punya one of the outcomes that we expect that you must be able to, apa tu? Conversion kan? Sekejap, tengok balik outcome tadi. Nah. Ini kan, converting transfer function pergi kepada state space. Kamu nak convert daripada transfer function pergi kepada state space. Sekarang ni, kita nak tahu juga daripada state space patah balik kepada transfer function. So we have to use the knowledge of inverse of the matrix A for us to compute the conversion from the set space to transfer function. Right. Okay, let's take a look at one of the example here. Find the inverse matrix for the following. Find the inverse matrix for the following matrix. Katakan kita nak ambil apa tu? Yang mana? Kita buat yang mudah sikit lah. Kita buat MD boleh. So if we want to find kita buat yang kita buat MD lah. Okay, let's try to do D. We know that to find D inverse is simply equal to the adjoint of the matrix D divided by the determinant of the matrix D. Okay, and then to find the adjoint of the matrix D is simply equal to the cofactor matrix of D transpose. To find the adjoint of the matrix D is simply equal to let me put the notation of the cofactor matrix for D. Boleh ke? Notation macam mana Dr. Jidah pakai? Saya pakai CD boleh ke?
Boleh.
Cofactor tu C kan. So since we are working on the matrix D, so let me denote the cofactor of the matrix D. The cofactor of the matrix D is C transpose D. Kan, C transpose CD to imply that this is the cofactor matrix of D transpose. Okay, and then we have to find CD. Macam mana kita nak dapatkan cofactor matrix untuk matrix D? Okay. Tengok balik dia punya formula tu. Cofactor matrix adalah, okay, tak ingat kan? Bila tak ingat, kita ambil. Ya, dia ada cara nak ni. Okay, cofactor, so kita ni. Right, lepas tu paste kat sebelah ni. Okey, nama kecil sangat ah. Right. Okey. Sebab kita nak guna yang ini. Yang ini kita ambil matrix D ni. Okay, matrix D dan kita letak kat sini. Okey, supaya kita nampak macam mana daripada formula ni untuk kita cari cofactor of the matrix D. Okey, ini adalah matrix D dan kita nak dapatkan dia punya cofactor ni. Okey. Right. Let's try to do it with me. Macam mana? Yang ini kan A22 ataupun kita ada CD. Cofactor matrix sama dengan Kita ambil yang ini. Determinant of A22. Yang ini kan. A22 ataupun kita akan dapatkan dia sebagai 0, 4. Kan 0, 4. S tambah 6. S tambah 6 dan ini adalah 1. Right. Kemudian kat sini pula. Kat sini dia akan jadi A21. A21, A23. Which is kita akan ada minus A21 adalah S tambah 2. Ini adalah 4 dan ini adalah 1 dan ini adalah 1. Kemudian yang ini pula. Kan untuk yang ini kita akan dapat dia akan jadi S tambah 2. Kita akan ambil yang ini which is S tambah 2, 0, 1 dan S tambah 6. Kan? Dapatkan cofactor matrix. So saya perlukan ruang lebih besar sikit. Jadi saya zoom in kita punya ni. So kita akan form big matrix here. Right. Kita dah isi yang atasnya. Nanti kita kira dia punya determinant. Kita tulis dulu. Kemudian tengok pula kepada second row of the cofactor matrix. Second row we got a determinant, kita ada minus, kita akan ada A12. A12 adalah ini kan, which is kosong. Kita akan dapat kosong. A12 adalah yang ini, 1. Row yang pertama, kolom yang kedua. Kita akan ataupun kamu nampak untuk dapatkan yang ini, tutup ini, kita ambil dia punya yang ini. Which is 1, 0, 1, 0, S tambah 6 dan juga 1. Kan, fahamkan pattern tu. Kalau you faham pattern, and then it should be very straightforward to compute the cofactor matrix. To get the element here, tutup ini. And then you take the rest of the elemen ni. Kita ada 1, 0, S tambah 6, 1. 1, 0, S tambah 6, 1. And then, kita nak ambil yang ini pula. To get this, let's say we take, tutup yang ini. Kan yang ini kita nak ambil kat sini, tutup yang ini. We will get, this gonna be plus with, we got S0, 1, 1. Okay, S0, 1, 1. And the last one, kita akan ambil yang ini pula. Kan tutup ini. And then kita akan ada minus. Dia akan jadi S1, 1, S tambahkan dengan 6. S1, 1, S tambahkan dengan 6. Okay. Next, kita nak isi yang kat bawah ni pula. Kat bawah ni pun sama juga approach dia. What we can do is tutup yang ini. Kan? We tutup ini. Tutup yang ini. So kita ambil yang ini. Which is gonna be plus 1, 0, 0, 4. Right? Kan? We take a 1, 0, 0, 4. 1, 0, 0, 4. And then the next one, kita tutup yang ini kan. What we can do is kita tutup yang ini pula. Tutup ini, and then it's gonna be minus S0, S plus 2, dan juga 4. Okay. S0, S plus 2 dan juga 4. And then the last one, what we can do is kita tutup kalau apa pula okay, tutup yang ini, and then kita akan dapat this is going to be plus with S1, S plus 2 dan juga 0. By the way, plus minus ni bukan operation tambah tolak that is just the sign. Okay, this is just to indicate the sign at this cell is going to be a positive value. Kan? At this cell you should have a negative value. So this should be a comma here sebenarnya kan. Matrix operation, you will get is going to be a comma ataupun the way we write it, we have to put, this is a matrix, 3 by 3 matrix. It's not a one sentence of mathematical expression. To indicate plus minus tu menunjukkan operasi tambah dan sebagainya. Okay, once we are able to construct this cofactor matrix, and then what we need to do is to compute all the element whereby from here kita boleh kira lah. Yang ini kita akan dapat dia akan sama dengan kosong darabkan dengan 1, which is kosong, tolakkan dengan 4, darabkan dengan S tambah 6. So we got here is going to be minus 4 S plus 6. Here we got this is S plus 1 times 1, kan? It's going to be minus S plus 2 times 1 minus with 4. Again, you have to be very careful on the bracket. If you do not have enough bracket ni, kan, kalau kamu tak ada cukup bracket ni, you might get some error in your computation. Kan? Sometimes people make mistake by not having enough bracket, so they simply assume ada beza kan? We got minus 1 dan minus 1 tambah minus S tambahkan dengan 2 dan juga minus, saya nak tunjuk lah. My point is, when you want to do the multiplication, you have to be very careful on this bracket here. Because the minus here is going to be outside of the big bracket. Dan kamu akan ada big bracket dekat sini. When you do the computation, you will be multiplying minus 1 with S plus 2 and minus 1 will be multiplied with minus 4. If you are not careful enough, you might get this is going to be some mistake for you to write this is going to be a minus 4. Point saya adalah kamu kena hati-hati dengan bracket. Right. Erase this part. Okay. What about this one? Here we can see that it simply is going to be S plus 2 times with S plus 6 minus 0. Okay. And then we do the same thing for the rest of the element. And then kamu boleh buatlah kat sini, you can dapat minus, this is going to be 1 minus 0, then minus 1. And here is going to be S minus 0, is simply S. And here is going to be minus S plus 6 minus 1. And the down here we will have, this is going to be 4. And down here is going to be 4S. And down here is going to be 0. S times 0 is going to be 0. 0 minus S plus 2. Okay. So that's how you compute for the cofactor of D. Kan? Dapatkan cofactor matrix D. Dan kemudian you can get the adjoint of the matrix D. Kan? Kita boleh dapatkan adjoint of the matrix D, whereby the adjoint of CD is simply equal to CD transpose. Kan tadi kita dah dapat cofactor matrix. To get the adjoint, you have to transpose that matrix. And when you do that, what we will get is, kamu kena apply transpose lah. When you apply the transposition of the matrix, which is going to be minus 4S plus 6. And this is going to be minus S plus 2 minus 4. And here we will get this is going to be S plus 2, S plus 6. Okay, it's going to be minus 1, S and minus S, S plus 6 minus 1. And here we got 4 minus 4S, and this is going to be minus S plus 2. So this is the adjoint for the matrix cofactor of D. Right. Where were we? Kat sini kan? So dapatlah dia punya matrix D, dan kemudian kita nak kena cari, you have to compute for the determinant of D. So, macam mana nak dapatkan determinant of D? How to compute for the determinant of D? Again, you can use any method that you prefer. We got 3 methods. Let's try one of them. Okay, katakan kita ada matrix D ni. Okay, how do we compute the determinant of D? Let's take one of the method that we learned previously. So to compute determinant of D, this is going to be S10, S plus 204, and here we got S plus 6 and 1. And then we repeat. Katakan kita repeat the first two column of D. It's going to be S1, S plus 2, 0, S plus 6. Then, the determinant is simply equal to, kita akan dapatlah kita punya determinant sama dengan, our determinant is, kita kena darab lah yang ni kan. Darab yang ini. Okay. Dan darab yang ini. Dan kemudian darab yang ini. Am I doing the... salah circle. So the problem is when you are writing on the tablet and then your eye is looking on the monitor and then you might get your angle off. So ini kat sini kan, kamu kena darab yang ini. You have to multiply this. So I have to be very careful this time. And then next you have to multiply this. Okay. And the next one you have to multiply this. Right? Then minus with multiplication of this, kamu multiply yang ini. Kemudian kamu akan multiply yang ini. Okay. And then kamu akan multiply yang ini. Right. Hopefully you guys can follow saya punya ni. So simply we got S times 0 times 1 is equal to 0. Plus with 1 times 4 times 1, which is 4. Okay. Times with 0 times S plus 2 times S plus 6. Kosong darab dengan S tambah 2, darabkan dengan S tambah 6, which is 0. Which is simply equal to 0. Plus equal to 0. Then, minus with 0 times 1, which is 0. So, kita akan dapat minus with 0. Minus with 0. And then, minus with S times 4 times S plus 6. Kan, S darab 4, darabkan dengan S darab 6. To give us minus with S, darabkan dengan 4, darabkan dengan S plus 6. Okay. Minus with, another one is going to be 1 times S plus 2 S plus 1. Minus with 1 S plus 2 S plus 2 and then plus with 1. And then we will get the determinant of the matrix T is simply equal to, you have to expand this expression. You got this is going to be 4. And then you got, ini adalah 4S. So this is going to be minus 4S square minus with 6, apa tu? Nanda dapat 24 kan? 24S. Okay. 24S minus with S plus 2, S plus 2. And in the end, you can arrange it properly. You get it's going to be minus 4S square minus 25S plus with 6. Okay, plus with 6. So you got the determinant of the matrix D. You have the adjoint of the matrix D. And then you can compute for the inverse of the matrix D, whereby the inverse of the matrix D, can D inverse is simply equal to adjoint of D divided by the determinant of D, which I will not write it here lah because it will take a lot of space. Tapi kalau you dalam test, you dalam exam, kalau soalan 3x3, you have to do it lah. Kan? When you are writing on your foolscap paper tu very easy lah kan, the line dan sebagainya. And then you must understand that to get the inverse of D is simply equal to adjoint of D divided by determinant of D. Right. So that's how we compute for the determinant ataupun how we compute for the inverse of a given matrix. All right. Any confusion on this part?
Sir, nak tanya.
Yes.
Yang bahagian tadi,
Silakan.
sir. Yang determinant. Yang minus S plus tu, bukan minus S minus 2 ke? Yang dekat bawah tu, sir.
Did I make any mistake? Okay, kat mana ni?
Yang bahagian hujung tu. Bawah, hujung.
Hujung. Can you control my screen?
Dekat bawah, dekat bawah.
Kamu pergi ke atas ni and then you click request control and then kamu tunjuk kat saya.
Macam mana,
Boleh
sir?
ke? Kamu dah guna laptop ke guna handphone?
Guna laptop.
Kalau kamu laptop, okey, kamu pergi dekat kamu punya tu kan, kamu ada request control kan? Kamu request control, nanti saya akan bagi you punya untuk control and then you boleh tunjuk kat saya dekat mana tu. Okey. Okey, so please tunjuk kat mana yang saya buat mistake tu. Okay, S plus 2. Okay, right, thank you. Betul. Maknanya saya silap kat situ. Okay, saya cancel control sekejap tu. Right, thank you for correcting me. Dekat sini dia akan jadi minus S plus 2 kan. Tu saya katakan hati-hati dengan kurungan tu. Sebabnya kita akan ada tendensi untuk buat mistake. Thank you very much for that. So you can see that it's going to be minus S plus 2, and bila kita ada S plus 2, calculation ni salah lah. Kira balik, mana kita akan dapatlah dia sebagai, we got here is going to be minus 4S kan, minus 4S square, and then minus 24 minus S is going to be minus 25S, and then you got 4 minus 2 is going to be 2. So dia akan tambahkan dengan 2. Right. Thank you. Any more confusion? Any more issues yang kamu nak highlight ataupun that you want me to repeat before I pass the button to Dr. Najidah?
Clear, sir.
Clear? Alright. Okay, so yang best guna MS Team tu one of the way you can control lah, tapi janganlah interrupt. Maksud saya tu janganlah ganggu. Kalau Dr. Najidah tengah mengajar tu you asyik request control kan. Tapi that is the beauty is you can interact, you can show where the mistake is and then you can pinpoint by using those features that I showed you before. Okay, itu cara untuk kita dapatkan inverse. So the rest of the example, I believe you can do that on your own as part of your exercise. And then I think that's all from me. And then the rest of the topic will be covered by Dr. Najidah about the singular, non-singular, metric and so on. And then again, thank you very much for listening to me. And then I wish ada soalan ke sebelum saya stop ni? Ada? Okay, I wish you guys all the best in your study, and I pray that you become a successful engineers that contribute to our nation. And then tadi lah, lepas ni ada kelas lagi ke ataupun habis session?
Tak ada kelas. Hari ni memang tak ada kelas.
Tak ada kelas. Maknanya kita stop sini and then content Dr. Najidah akan sambung balik pada masa lain lah.
Betul.
Okay.
Betul.
Okay, thank you. Okay, kalau tak ada apa-apa, kita stop dulu di sini. Again, saya ucapkan terima kasih kepada kamu untuk sudi mendengar perkongsian daripada saya pada hari ini. InsyaAllah kalau kita jumpa Shah Alam ke kat mana-mana, please tegur saya. Saya tak nampak kamu dan tak tahu you punya faces. And then feel free to contact me. Nak tahu master akan datang ke, rasa orang Pahang nak buat kat UMP, boleh contact saya lah, insyaAllah. Okay, that's all from me and see you guys again next time, insyaAllah. Okay, thank you all. Thank you, Dr. Najidah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to Dr. Muhammad Syakirin Rapli from UMP. So this semester kita ada satu slot sahaja, which is this week untuk 2 hours. Maybe next semester kita boleh arrange untuk at least few more slots sebab this semester is first time kita buat collaborative teaching. So untuk students, thank you very much for your attendance today, sebab sepatutnya hari ni college engineering memang declarekan jadual hari Jumaat. So hari lain kita dah vote, memang tak ada kelas hari Jumaat. Kita akan continue topik state space next week untuk group B hari Isnin pukul 2, untuk group A hari Selasa pukul 2. Okay, that's all for today. Let's end our class with Ustaz Baker for Surah Al-Nas. Okay, thank you very much. Thank you, Dr. Syakirin. Thank you to all students. Assalamualaikum. Salam.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.